All right, so we know our trig ratios, we know how to find our sides, and we know how to find the angles. Now we're going to use our trigonometry to find our area. We know the area of a triangle is 1/2 the base times the height. One thing that I always make sure everybody knows, base and heights are always perpendicular to each other. Okay, if we don't know the height, okay, a lot of times we know the base, we don't know the height, we can figure it out using trig. So we can go through and we could do all this trig out here, or because it's in our formula sheet, we can just use this formula, okay? This leads us to this formula, A equals 1/2 AB times the sine of C. And the reason why this works is if this right here is our height, and this is our angle, C, the height is, if we go through and we were to write this, this is our angle, the sine of theta equals H over A. H over A. Opposite over hypotenuse. Then we solve for H, and that gives us H equals sine theta. Then if we go to our problem, 1/2 base times the height, okay, that's our area. But here our height is just sine theta, or A sine theta, sorry, A times sine theta. We multiply both sides by A, okay? So instead of this height, we write A times sine theta. We get A equals 1/2 times B times A times the sine theta, which we can just rewrite as A times B. And so that's where we get. And our theta here happens to be C. Okay? The important part of this formula is knowing what sides to use and what angle to use. Okay, the rule for this, the important part of this formula is that A and B can be any two sides, but the angle C must be in between them. Okay, if it's not in between them, then we're not going to be able to use this formula. Okay, it always has to be the angle that's in between these two sides. If it's this angle over here, we can't use this formula. Okay, so if we look at this, if you're looking at this and you're counting in order, I don't know if you guys remember congruent triangles, but this one was side, angle, side. So this only works on triangles where we know the two sides and the angle between them. Okay? If you know that, it's great. It's on your formula sheet. Boom. No, it's in Unit 3. Right here. It's there, ready to go. The other two rules we're going to learn in this chapter, sine rule and cosine rule, are right there. All right, so find the area of the following triangles. This one's nice and easy. The area, here's your base, here's your height. We know their base and height because they're perpendicular. So this is just 1/2 18 times 6. Okay, which gives us, punch it in the calculator, gives us 9 times 6, which is 54 units squared. All right, this one right here, we don't know the height. We do know a base, but if we were to flip this table or this around, then that would be our height and this would be our base. We don't want to go through and find that. So we look and we say, does our sine area formula work? Remember, we have to, in order to use y equals 1/2 AB times the sine of angle C, which is in between A and B, it has to be side, angle, side. So that works. We do have side, angle, side. So we can just plug it into this formula. Area equals 1/2 9 times 11 times the sine of 20 degrees. And let our calculator do all the work. So 1/2 is 0.5 times 9 times 11 times the sine of 20. 16.929. So the area of this is 16.9 centimeters squared. Notice how I'm always doing it in 3 significant terms unless the question asks differently. Next one, we know the base is 6, but we don't know the height because they have to be perpendicular. But we do look and we got side, side, and the angle in between them. So we've got side, angle, side. So we can do our formula. 1/2 area equals 1/2 6 times 5 times sine of 30. 1/2, so 0.5, times 6 times 5 times the sine of 30. And that gets us 7.5 centimeters squared. All right, so this one looks weird. We're finding the area of this beige triangle right there. But the height is from the base directly up to there. And remember, I told you it always has to be perpendicular. So this is our base, this is our height. 1/2, 8.5 times 14. Punch it in the calculator. 0.5 times 8.5 times 14 gives us 59.5. 59.5 inches squared. We're done. The Burj Al Arab luxury hotel in Dubai, United Arab Emirates, is located on an island 280 meters from Dubai Beach. A land surveyor who is 1.78 meters tall, standing at the shore of the Dubai Beach, measures the angle of elevation to the roof of Burj Al Arab to be 36.6 degrees. How tall is the Burj Al Arab? Seems really weird. Why would they tell us how tall he is? All right, so I'm gonna have to look this one up because that one's weird. I did all these, but I don't remember the 1.78. Okay, so while I'm looking this up, sorry guys, you should be drawing a picture. Anytime we get a word problem in this chapter, look to draw triangles. Look to draw triangles every single time. All right, I see what they did now. Okay, here we go. So if they give you the information, then you're going to have to use it. Here's the Burj. That's that weird looking sail looking thing like this. Here's this guy. He's 1.78 meters tall. He's standing up here. He measures the angle of elevation. So angle of elevation start at the horizon and they go up. And that's going to be your angle. This one down here is called angle of depression. So angle of elevation. And then this one down here is called the angle of depression. So definitely know those because they can just throw those in at any time. Just think elevation goes up like an elevator. Depression goes down. Okay. All right. So 1.78. This guy's standing right here. He's 1.78 meters tall. He measures up here to the top of this Burj Arab, blah, 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 blah. And he says that angle right there is 36.6 from the horizon. So we're going to come over here like this, and we're going to draw our right triangle. So this right here is 36.6 degrees. We can assume, you can assume any buildings, people standing, trees, anything that where they're asking you to do these on these problems, you can assume that they are perpendicular to the ground. Okay? You can assume they're perpendicular to the ground. Unless stated otherwise, always assume. I had a student last year who would always go, well, what if they were standing at 20 degrees? Or what if they, always made up these long stories on it, but it didn't help her out at all. Okay, we know the distance from this man to the building is 280 meters, and we're trying to figure out how tall it is. Okay, so what we're going to do is we're going to figure out how tall this is, and then we know because this guy's 1.78 over here, this little pit right here is 1.78 because this is 100% horizontal. Okay, so do you see the right triangle? Hopefully you do. Looks like that. Right triangle. We know this side right here is the opposite side. This side right here is adjacent. This side across here is the hypotenuse. We're not even worried about that. Okay, so we're going to use adjacent and opposite. Adjacent and opposite, and we go so, ka, toa, and that means we're going to use tangent. So we say the tangent of 36.6 degrees equals the opposite, x over the adjacent 280. Isolate x, we multiply both sides by 280. Those are going to cancel out. We punch it into the calculator. 280 times the tangent of 36.6 degrees gets us 207.946. 207.946 equals x. Now that's just this piece right here. Okay, we've got to make sure we add in this 1.78. So before you've done anything on your calculator, just press plus. It brings up an answer plus 1.78. That gets us 209.72. So x equals, when we add these up together, 209.72. Three significant figures is 1, 2, 3. Look to the right, it's a 7. So we would say 210 meters tall. All right, on your own, let's see if you guys can figure out the trig ratios for those. Find the x in these three right there, find the area, and then on our classwork, we will be doing a lot of word problems. Hopefully, you guys got this under control. You're ready to go. Looking forward to getting a good grade on this trig stuff.